Are you trying to study physiology and feeling lost? In Unraveling Human Physiology, I will try to make physiology easier for you to understand. I choose body acid-base regulation because I know it's a very difficult subject to understand. As it is complex, I divide the explanation in several videos. Look at all of them and then you will be able to integrate and understand as a whole how the body managed to regulate body acid-base status. In this part, we are going to discuss why is pH so important. Turn your TV or look at some videos and I'm sure someone will be talking about pH. This shampoo has a balanced pH. This water has neutral pH. What's the pH of these fruits? An acid pH will ruin your crops. It's important to control the pH of your aquarium. Why is pH so important? So let's start by defining what is pH. pH equals minus the logarithm of hydrogen ion concentration. So when we are talking about pH, we are talking about hydrogen ion concentration. And why are hydrogen ions so important? Is it because they are big? No, they have a tiny mass, just one atom with no neutrons, only protons. That's why we usually call them protons. Are protons important because there are many in the body? No. Let's do the math. Normal extracellular pH is about 7.4. If pH is minus the logarithm of proton concentration would be 10 to minus pH. 10 to minus 7.4 is 3.8 times 10 to minus 8 equivalent per liter. So that is 0.0000038 equivalent per liter. Try to read this in an analysis and understand if your patient has a normal extracellular protons or not. That is very difficult. So it's a lot easier to understand if you transform this number to pH. That will vary between 1 to 14. How is this concentration if we compare to other ions in the body? Normal extracellular proton concentration is 0.00038 milliequivalent per liter. Sodium, which is the most abundant cation in the blood, has a normal extracellular concentration of about 140 milliequivalent per liter. So if we compare those two, you would see that sodium is about 3,500 times more abundant than protons. If the concentration of protons is 1 gram of salt, the concentration of sodium would be 3.5 kilos of salt. So let's put it in a more graphical way. Let's go to the kitchen. Where do you find a gram? A gram of salt would be about a teaspoon of salt. 3.5 kilos of salt is very difficult to put together in the kitchen, so let's choose another thing. 1 kilo of apples is about 4 apples. So 3.5 kilos would be 14 apples. So graphically, the concentration would be for protons a teaspoon of salt and for sodium 14 apples. Then why is it so important? It's about its reactivity. In water, hydrogen ion is not really free. It's a tiny mass with a positive charge, resulting in a molecule of high density of positive charges that will attract any electronegative molecule. In water, oxygen is very electronegative because it has two uncoupled electrons that will attract protons. This results in a new molecule with a coordinate bond with the proton called hydronium. So, in water, hydrogen ion plus water equals hydronium. So remember this key point. Hydrogen ions are very important because they are very reactive. If you like this video, please give me a like, subscribe to my channel,
and activate your notification to know when my next video will be on. Thanks, bye!